We will be using trig identity manipulatives to prove a trig identity. Here we have secant theta over cosine theta minus tan theta over cotangent theta, all equal to 1. Since the reciprocal of secant theta is 1 over cosine theta and the reciprocal of tan theta is sine theta over cosine theta, and the reciprocal of cotangent theta is cosine theta over sine theta, you can arrange secant theta over cosine theta minus tan theta over cotangent theta to 1 over cosine theta all over cosine theta over 1 minus sine theta over cosine theta all over cosine theta over sine theta. This step changes everything to sines and cosines.
Because dividing fractions is the same as multiplying by the reciprocal, 1 over cosine over 1 is the same as 1 over cosine times 1 over cosine. And sine over cosine over sine would be the same as sine over cosine times sine over cosine, making the equation 1 over cosine times 1 over cosine minus sine over cosine times sine over cosine.
By simply multiplying on either side of the minus sign, 1 over cosine theta minus 1 over cosine theta would turn into 1 over cosine squared theta, and sine theta over cosine theta times sine theta over cosine theta would turn into sine squared theta over cosine squared theta, turning the equation into 1 over cosine squared theta minus sine squared theta over cosine squared theta, making the denominators the same so that we can show how to combine the fractions.
Since the denominators are now the same, we can subtract 1 over cosine squared theta minus sine squared theta over cosine squared theta to get 1 minus sine squared theta over cosine squared theta.
Since 1 minus sine squared theta is the same thing as cosine squared theta, we can change 1 minus sine squared theta over cosine squared theta to cosine squared theta over cosine squared theta, which is equal to 1. Both sides are now the same, and our trig identity has been proven.